Time for some local linearization. This is really nothing more than just using a tangent line to a curve, a particular function, to approximate a curve at a certain value. All we're doing is looking at a line that sort of looks like the curve, close by the curve, to approximate a value near where that tangent line is formed. So let's take a look at the function f of x equals x squared plus x plus 3, and we're going to use the tangent line at x equals 2 to approximate f of 2.1. We then will determine whether we think this is going to be an over or an underestimate. So to start, if this is f, we need to find f prime of x, so we can find the equation of the tangent line. F prime equals 2x plus 1, easy enough. So f prime of 2 would be 2 times 2 plus 1, or 5. So the equation of my tangent line is going to be y minus my y value. Well, I don't have that yet, so we'll grab that in a second. Times 5, the slope, times x minus my x value. I need to go get my y value at x equals 2, so f of 2 equals 2 squared plus 2 plus 3. F of 2 equals 4 plus 2, which is 6 plus 3, 9. So y minus 9 equals 5 times x minus 2 is the equation of the tangent line at that particular point. So now we can use it to approximate f of 2.1. All I need to do is y minus 9 equals 5 times 2.1 minus 2. Just putting this in here is going to help me approximate this. What's really happening is, for this particular curve, just x and y, whatever this looks like at 2, right? If we said that this is at 2, I have this tangent line. And I'd like to know, well, I don't know the output here at 2.1, so I'm going to use the output on my tangent line to approximate what that would be. So y minus 9 equals 5 times 0.1. We end up with y equals 0.5 plus 9, y equals 9.5. Now, that means that I have an output here of 9.5. That's the approximate output value for my curve. So y equals 9.5. Well, is this an over or underestimate? And we'll get into this more in later chapters, but for now, just consider what this function looks like. This function, we say that it's a concave up curve. Anytime I have a concave up curve, I have tangent lines that are going to lie underneath the curve. Therefore, no matter where on this curve I put a point, or on these lines I put a point, these points are always going to lie under my curve, and therefore this is going to be an underestimate.